Hi guys, this is another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance that this should happen. So today, we're going to be going over lesson 3.4, multiplying decimals. So, our first example, we're going to be multiplying a decimal by a whole number. So we've got multiply 0.4 or 4/10 by 3. Before we start that, we're going to note that when you multiply things, you can multiply in any order. So 0.4 times 3, it is the same as 3 times 0.4. Now, why is it the same? Because of a property called the commutative property. The commutative property states that multiplication can be done in any order. And that might be useful for us in order to, we might want to rearrange our numbers to make the problems easier for ourselves when we want to multiply them. So we need to keep in mind that we can rearrange them, we can multiply them in any order, and we're still going to get the same answer. We just need to decide which order is going to be the best. Okay, we're going to do this problem twice. The first time we multiply it, just want to go through a nice visual showing you what this problem means or looks like. So I'm going to stick with the rearrangement where we had 3 times 0.4. Now as I write this, I'm going to take off that 0. If you have a 0 that is not sandwiched between numbers or decimals, it's not necessary. So I don't like writing things that aren't necessary, so I'm going to leave off the 0. It does not change the value. It's still 0.4 with or without that 0. So if the 0 is not sandwiched between numbers and or decimals, you don't need it. It's a waste of time. So I'm going to write 3 times 0.4. Just want to note what this means. First of all, this means you have 3 groups of 0.4. So if we were to visualize that, let's draw a number line real quick. If I were counting by 0.1s or 1/10, 0.1, 0.2, 0.3, 0.4, this would be one group of 0.4. Well, I want 3 times 0.4, so I want 3 groups of 0.4. So if I were to continue, I'd have 0.5, 0.6, 0.7, 0.8, so there's another group of 0.4. So one more group, 0.9, 1 whole, 1.1, 1.2. Oops. So 1, 2, 3, 4, another group of 0.4. So we have 3 groups. What does that mean? I have 3 batches of them. And what's that going to add up to? It's going to add up to 1 and 2/10, or 1.2. So 3 times 0.4 is equal to 1 and 2/10, or 1.2. Now that's just a nice visual of what we're doing or what it means. Now I'm going to show you the most direct approach to solving these problems, which is basically write your problems vertically. So typically we want to write the one that's longer, the one that has more digits on top. Since I changed it and chopped off that 0, they're both the same size. I have 1 digit, 1 digit, so it really doesn't matter. So I'm going to go back to the original. 0.4 times 3, Again, it really doesn't matter what order. So 0.4 times 3. You'll notice I did not line up decimals. The decimal in 3 is right there, up its backside. So you do not line up decimals on multiplication of decimals. What do? You line up your numbers. So make sure they're all lined up like that. Do not mess with the decimals. Don't line them up. That's adding and subtracting. Now, all you have to do is multiply like normal. So 3 times 4 is 12. Okay, now what do I do with the decimal? You need to count how many numbers in the whole problem are behind a decimal. So I only have one number behind the decimal, the 4. The 3 is not behind a decimal, so I don't include it. So there's one number behind the decimal. So what am I going to do? I'm going to look at my answer and make sure that one number only is behind the decimal. So only the 2 in this case. So my answer is going to be 1.2, or 1 2/10. Now, let's just make a quick observation. If I were to take these same numbers, but remove any decimals, I would have 4 times 3. If I took 3 times 4, I would have 12. So if you look at this answer, and look at this answer, they're essentially the same, but without a decimal. So this one, notice the problem doesn't have any decimals. My answer doesn't have any decimals. This problem does have decimals. The answer has decimals. So this one is the same, but without decimals. So what does this mean? It means that when you're multiplying, you just multiply like normal, and then you figure out where your decimal is going to go at the end. That's really all there is to it. So that's really what we're going to be practicing today, figuring out where a dot goes. All right, example 2. Alex wants to place 7 decals, that would be a sticker, of his favorite band on his bulletin board. If each sticker or decal is 1,500 meters wide, how wide does the bulletin board need to be to fit all of his stickers in one row? So we're going to stick with, oh, I keep on messing up. Darn it. We're going to stick with the vertical method. I'm just going to jot down a couple steps to remind yourself of. First, we write the longer number on top, not the bigger, the longer one on top. It's going to make your life so much easier. And second thing to keep in mind, unnecessary zeros do not need to be written. Unnecessary zeros do not need to be written. So write your longer numbers on top, and then don't mess with unnecessary zeros. So on this one, that 0 is not sandwiched. Let's not bother writing it down. It's a waste of our time, and it makes the problems look more confusing. Okay, so let's work out this problem. I have 7 stickers that are this size each. That means we're going to multiply. Which one's longer, 7 or 0.15? The 0.15 is longer. It's got 2 digits. This only has 1 digit. So I'm going to write the 0.15 on top. I'm not lining up decimals. I'm lining up numbers. Now I just pretend that the decimal doesn't exist, and I just start multiplying. 7 times 5, 35. Write your 5, carry your 3. 7 times 1 is 7, plus 3 is 10. So now I have 105. Now you have to figure out, where does your decimal go? Do you bring it straight down? Do you count? You have to count. You do not just bring it down. So 1 is behind the decimal. 5 is behind the decimal. The 7 is not behind a decimal. So how many numbers are behind the decimal? We have 2 numbers behind the decimal. So this is what you're going to do. You're going to start on the right and move your decimal so that there are 2 numbers behind the decimal. In this case, the 0 and the 5 are the two numbers that are going to be behind the decimal. So our answer is going to be 1.05. And it's a word problem, so we're going to, of course, put it in a sentence. So our answer is, how wide does the bulletin board need to be? The bulletin board needs to be 1 500 meters. So again, essentially, we just multiply our numbers normally, and then you figure out where the decimal goes by counting how many numbers are behind the decimal in the entire problem, and your answer should match. So, quick observation. So if I were to remove all the decimals, and I take 15 times 7, 7 times 5, 35, 7 times 1, 7, plus 3, 10. Again, the same numbers, but this problem doesn't have decimals, so the answer doesn't have decimals. This problem does have decimals, so your answer has decimals. So essentially, it's the same, but no decimal. All right. Example 3. We're going to multiply tenths by tenths. So our example is multiply 4 tenths and 5 tenths. Those zeros are not sandwiched between anything. There's a decimal on the back, but there's nothing in front, so it's not sandwiched. It's not needed. The same with this 0. So I'm not even going to bother with them. All right, I'm going to show you 2 different ways to do this. No, it doesn't involve pictures. So 4 tenths times 5 tenths. Again, remember that 0.4 times 0.5, same as 0.4 times 0.5. I don't need those zeros. They're not sandwiched. Okay, let's start this. 0.4 times 0.5. I was not trying to line up the decimals. It just happened. What was I trying to do? I was trying to line up the numbers. That's what you do. Okay, now let's pretend that the decimals don't exist. And multiply. 5 times 4, 20. Now, do I bring the decimal straight down? Absolutely not. You count the digits behind the decimal. The 4 is behind a decimal. The 5 is behind a decimal. That would be 2 numbers behind the decimal. So, what does this mean? Move that decimal once, twice, so that you have 2 numbers behind the decimal in your answer. So our answer is 20 hundredths, or 0.20. Now, I would also, or any teacher or anyone would accept 0.2 as well, because that 0 is not sandwiched between anything. So 0.2 or 2 tenths would be acceptable as well. But we already have it. Why not just box it in as your answer and be done with this? Okay, what's another way you could do this? Well, some people like fractions. I know, weird, right? Well, start out by writing your problem. 4 tenths times 5 tenths. Well, if you like fractions, why not just convert them to fractions? So 4 tenths is literally 4 tenths, or 4 over 10. We're multiplying. 5 tenths is literally 5 tenths. And now just multiply fractions. I'm not going to mess with cross canceling. 4 times 5, 20. 10 times 10, 100. Now, how do you read this instead of saying 20 over 100? Well, this would be read as 20 hundredths. So once I get my fraction, I'm going to convert it right back to decimals because that's how the problem started. I should probably finish my answer like that. So 20 hundredths is written as 0.20, 20 hundredths. So if you like fractions instead of decimals, convert your decimals to fractions, do your business, and then convert it right back to a decimal to match what the question originally was. Next example. We're going to multiply 2 decimals with 1 decimal place. So notice we've got two different decimals, and they both have one decimal place. Now we're getting into where we have like whole numbers in there as well. First step, stack them on top of each other and write the longer one on top. So I have got 2.8 and I've got 0.3. I'm going to ignore that 0. It's not sandwiched. It's not needed. Let's not deal with it. So the longer one goes on top, the 2.8. We're going to multiply it by the 0.3. No, I was not trying to line up the decimal. It just happened. It was a coincidence. Okay, 3 times 8 is 24. 3 times 2 is 6. Plus 2 is 8. Now, how many numbers or digits are behind the decimal? 1, 2. So, move your decimal once, twice. The decimal is going to be right in front of the 8. Now let's write our answer. That's not an answer. That's a bunch of work with a bunch of squiggles. So, your answer is 84 hundredths, or 0.84. Remember, multiplying numbers, it's identical, just with a dot or without. Oops, did not mean to do that. So if I were to take 28 times 3 without decimals and just multiply, I should expect to get 84. So 3 times 8, 24. 3 times 2 is 6, plus 2 is 8. It's the same thing. One without decimals, one with. All right, example 5. 3 and 6/10 times 1 and 2/10. So they're both the same size, so it doesn't matter which one goes on top. So I'm just going to write the first one on top, 3.6. Put the second one on bottom. Again, I was not trying to line up the decimals. I'm lining up the numbers. That just happened. Okay, multiply like normal. 2 times 6 is 12. 2 times 3 is 6. Plus 1 is 7. I'm done with the 2. Done with that one. Get rid of them. Add a 0. Why? Because you need to push yourself over into the second column. We are in this place value now, not in this one. So 1 times 6, 6. 1 times 3, 3. What are we going to do with these? We're going to add them, of course. 2 plus 0 is 2. 7 plus 6 is 13. Pretty sure. And then 3 plus the one we carried, don't forget those, is 4. The answer is not 432. Why? Because I have decimals. I'm expecting to have decimals in my answer. So where does it go? I've got one number behind the decimal, two numbers behind the decimal. Because there are two numbers behind the decimal, that means there should be two numbers behind the decimal in the answer. So 1, 2. The 3 and 2 have to be behind the decimal to make a match. So our answer is 4.32, or 4 and 32 hundredths. By the way, if I were to do 36 times 12, I'm pretty sure the answer would be 432, because it's the same. Last example, maybe. We're going to multiply decimals with one or more decimal places. So notice now I have two digits behind the decimal here, one digit behind the decimal. So we're just, going crazy here. Which one's longer? Well, I'm going to ignore that 0 because it's not sandwiched. It's not necessary. They're really the same. So I'm going to write the 0.56 first. I'm not writing that 0. It's a waste of time and it's just going to confuse. Times 1.2. Notice I did not line up the decimals. That's not what you're supposed to do. Don't do it. Line up your numbers. 2 times 6, 12. 2 times 5, 10. Plus 1 is 11. I've multiplied the 2. It's done its job. Done with that one. All right. Add a 0 because now you are in the second place value. 1 times 6 is 6. 1 times 5 is 5. Now we're going to add those together for our answer. 2 plus 0 is 2. 6 plus 1 is 7. 5 plus 1 is 6. Now where does the decimal go? Let's count. One number behind the decimal, two numbers behind the decimal, three numbers behind a decimal. So I better have three numbers behind the decimal in my answer. So one number behind the decimal, two numbers behind the decimal, three numbers behind the decimal. So our answer is 0.672, or 672 thousandths. Before we stop, I am going to do one little extra problem. Darn it, I ripped my paper. That makes me sad. Okay. Let's do 0.2 times 0.2. Well, 2 times 2 is 4. How many numbers are behind the decimal? 1, 2. So I need two numbers behind the decimal. Oh, I only have one. Well, let's just start moving the decimal. One number behind the decimal. I need two numbers behind the decimal, so the decimal needs to be like way over here. So what do I do with empty spaces? Well, we fill them with zeros. Zeros are like friends. You can get rid of them. You can add them. They fill the void, basically. So anytime you have empty spaces, fill it with a zero. So our answer on this would not be 0.4. It would not be 4. It would be 0.04, or 4 hundredths. Be careful with problems like this. Always count the number behind the decimal. Do not bring it straight down. Make sure you're following those rules. And make sure you don't get too aggressive with math because you'll rip your paper. I hope this has helped. If it hasn't, I hope you can find what you need somewhere else. Y'all have a great day.